Welcome students. I am Dr. Jebra is taking a real, fluid dynamics for you. Okay. The first topic we know well. The first topic here in the fluid dynamics. Let me go back to the syllabus. And you see here so fluid dynamics and the course code is 18P4MA15 and also 18 to 20 and it is coming in the fourth semester. So now coming to this kinetics of fluid dynamics, that's what we are going to talk about now. Okay, so in this let us go back to the notes. You will see here the third page, fluid dynamics. Okay, so what is a fluid dynamics? You must understand that fluid dynamics is nothing but a study of fluid in motion. Okay, it is not at rest, it is in motion when the fluid is moving. A lot of forces are acting on that. Am I correct? And that is called fluid dynamics. Fluid dynamics means study of fluid in motion, not at rest. Some fluid, take for example water. When the water is placed on the floor, it is moving. Am I correct? So how it is moving, why it is moving, when it moves, what is the mathematical formulation? Studying those things are called fluid dynamics. Fluid dynamics. Okay. Now, next one is about fluid. Fluid. Okay. You understand what is a fluid? Fluid is a substance which can flow. Take for example a stone. It is not a fluid because it will not flow. Am I correct? Similarly wood. Wood is not a fluid because it will not flow. But any substance that can flow is called fluid. Example, we can say water, oil, and tar. Tar, you know what is that tar? Tar means the substance used to make roads. Am I correct? That's called tar. So these are examples for fluid. Okay. Now, what is a liquid then? A liquid is a material which cannot flow. Why it cannot flow? Because volume does not change. Volume does not change when pressure is changed. That is why the liquid is not flowing. Okay, so what we understand, there are mainly two things. One is called liquid, is volume does not change when pressure change. Fluid means a substance which can flow. Okay, one type of fluid is a liquid where volume does not change when pressure change. Now, what is a gaseous? Gaseous is opposite of liquid. Gaseous is opposite of fluid. That means volume changes when pressure changes. Volume changes when the pressure changes. Then we say that it is a gaseous. Now, what is a hydrodynamics? Hydrodynamics is the science of moving in what is that? Compulsion fluid. Okay, science of moving in compulsion is called hydrodynamics. Hydrodynamics, we can say. Okay, now what is an ideal fluid? Okay, so all these are real fluid. Now, what is an ideal fluid? Okay, so now we come to the concept of mathematics. So, what is that concept? And that concept is the basic for ideal fluid, concept for basis of ideal fluid. Okay, so ideal fluid, a continuous fluid, we can define a fluid particle contained in infinitesimal volume, whose size can be treated as a geometrical point. Okay, this is what we can say an ideal fluid. An ideal fluid. Now take for example here, this is a water particle and this is continuous one fluid, continuous fluid, and one fluid particle I am taking there. It is infinitesimal, very, very small, very small to define volume, whose size can be treated as a geometrical point. So simply saying, what is the meaning of the ideal fluid is that any particle which is very small particle on the continuous fluid can be taken as a geometrical point, then we can say that it is a ideal fluid. But in the real fluid, a small particle which is infinitely very minute cannot be treated as a geometrical point, a mathematical point. But in the ideal fluid, it is possible. Since it can be treated as a geometrical point, we can apply all mathematical concepts. Okay, so all mathematical concepts we can apply, because we are not taking that as a fluid, but we are taking that as a point. When the point moves, then the whole phenomena starts. Okay, so that's what we talk about the ideal fluid. Okay, so the small infinite parts of this particular fluid can be treated as a geometrical point. So if you treat it as a geometrical point, we can apply all concepts of mathematics. And since it is connected with physics, we can use the idea of physics here. That is a dynamical idea. Dynamics idea we can use here. That's what we have to understand. Now, how we are defining the velocity of a fluid at a point Q. Now, take the point here. Q is not a point. Q is a velocity we are defining here. Now look at this particular picture, okay? Now suppose Y is a point. From this point to P is here, a small increment to P dash. So small increment is P dash. And that we are taking as del R. Del R. Now let this as a R. From here to here is R plus del R by using vector analysis. Okay, by using vector analysis, we can take OP dash is R plus del R. Right. Now, as del T tends to 0, when the time is tends to 0, what is the difference between del R and del T? Del R and del T. And that we are taking as dr by dt. Okay, and this we call it as the velocity of a moving particle from P to P dash. Therefore, Q is equal to dr by dt is called the velocity of a fluid at a particular point. We can say this is P, we can say, okay. So the representation of the particular velocity, we are saying Q equals Q of R comma T, where R is the time of movement and T is the time. So with that, I come to the end of this. The next class we will be discussing other topics. Thank you very much.